California has the most inspected bridges in America, and one of the highest concentrations of bridges that federal engineers have classified as being in poor condition. Both of those things are true at the same time. In 1989, a section of the Bay Bridge fell onto the cars below it during the Loma Prieta earthquake. Engineers had flagged concerns about that span for years. The western span, the original structure, is still there. You cross it today. California has over 13,000 state bridges. A significant number of them carry deferred earthquake protection work that was approved, funded in phases, and still isn't finished. Caltrans publishes every inspection report. The data is completely public. But here's the thing. In poor condition doesn't close a bridge. It opens a maintenance queue. The 10 bridges on this list aren't chosen because they look dramatic. They're chosen because experienced California drivers, truckers, locals, people who cross them every day, slow down on them. And once you know what they know, you will too. Starting at number 10. You're on the Vincent Thomas Bridge in San Pedro, suspension cables above you, the Port of Los Angeles sprawling out to your right. It's 1,500 feet across the main span, and it carries hundreds of industrial trucks every single day. The bridge was built in 1963, before modern earthquake standards existed, and it was retrofitted in the 90s to handle seismic shaking. Here's what the retrofit actually means. The bridge is designed to move. During a major earthquake, the deck shifts laterally. Not a little, several feet. The bridge survives that. Whether the vehicles on it survive is a separate question that nobody officially answers. Caltrans lists the seismic work as completed. But the 2019 Ridgecrest earthquakes forced engineers to revise California's fault models significantly, and those new models haven't triggered a new retrofit review for this bridge yet. The Port of LA is the busiest container port in the Western Hemisphere. Vincent Thomas closure, even a temporary one, starts unraveling national supply chains within 2 days. The retrofit didn't make it safe, it made it survivable. Those aren't the same thing. The next bridge on this list didn't just shake. Pieces of it came down on regular days, with no earthquake at all. The Richmond San Rafael Bridge carries I-5 805.5 miles across San Francisco Bay. 75,000 vehicles every single day, 2 decks stacked on top of each other, open water on both sides, nowhere to go if something goes wrong. Concrete and debris have fallen from the upper deck to the lower deck. Documented incidents, not earthquake damage, just age, just a regular day, just gravity doing what gravity does when concrete gets old enough. The bridge dates to 1956, and the seismic retrofit work has been ongoing since the 90s. Sections have been completed as funding cycles allow. Some sections are still original, and here's what nobody tells you. From the driver's seat, the completed sections and the original sections look identical. The scary part isn't that it hasn't been fully fixed. It's how normal the unfixed parts look when you're driving past them at 60 miles an hour over deep water with no alternative crossing for miles in either direction. Concrete falling from above is the kind of danger you can at least imagine. Number 8 fails from something you will never see coming. You're on I-80 crossing the Carquinez Strait, the gateway between the Bay Area and Sacramento. There are 2 bridges here, sitting side by side, and from your car, they look like a matched pair. One was built in 2003, one was built in 1958, before the 1971 Sylmar earthquake rewrote everything California thought it knew about seismic risk. The 1958 span was supposed to be demolished after the new bridge opened. The timeline shifted, then it shifted again. It's still there, still carrying traffic, still running on its original earthquake specification. You cross 2 bridges that look identical. One was built with 50 years of earthquake science behind it. One wasn't. There's no sign telling you which lane puts you on which bridge. I-80 is the primary corridor between Northern California's 2 biggest population centers. If Carquinez fails, it doesn't just close a bridge, it cuts the state in half. Caltrans has confirmed the 1958 span will be demolished. They've confirmed it multiple times. The new date keeps moving. The old bridge keeps carrying your car. Number 7 looks modern, looks recently maintained, and it has something moving through it right now that you can't see. Pull up any postcard of the California coast, and there's probably a bridge in it. Graceful arch, Pacific below, the kind of thing that makes people stop and take photos. What the postcard doesn't show you is what the ocean air is doing to the steel inside that concrete. Right now, today. Salt doesn't just rust metal on the surface. It works its way into the concrete And once it's in there, it runs a slow electrical current through the steel reinforcement, hollowing it out from the center while the outside looks fine. Coastal California bridges age 2 to 3 times faster than inland structures because of this. Some segments of the Pacific Coast Highway have no inland alternative for emergency vehicle access at all. The bridge isn't just a convenience, it's the only way in or out. Caltrans runs more frequent inspections on coastal bridges, but visual inspections can't detect what's happening inside the concrete without drilling into it, and drilling into a heavily trafficked, scenic coastal bridge is a process that involves lane closures, environmental review, and political friction. The ocean view is the whole problem. Every beautiful coastal bridge you've ever photographed is fighting the same invisible enemy. Number 6 takes you inland, to a bridge that survived the last big earthquake, and engineers are now quietly debating whether that was engineering or luck. In 1989, the Cypress Street Viaduct in Oakland collapsed during Loma Prieta. 42 people were killed. The structure was a double-deck elevated highway, the same design family, the same construction era as dozens of overpasses that are still standing across California right now. After Cypress, California launched the largest bridge retrofit program in American history. Billions of dollars, decades of work, and it's still not finished. Number 6 is a Bay Area overpass from that same 60s-era design family. Retrofitted, but the early retrofit waves focused on the columns. The connection point where the road deck meets the support column? That's a different piece of hardware, and it wasn't always included in the first round of fixes. California fixed the columns. Some of them forgot the joints. Number 5 sits over a major Central Valley river, and it carries 2 failure modes at the same time: earthquake risk and the kind of riverbed erosion that took out a Tennessee bridge in 1989 and killed 8 people. Caltrans treats those 2 risks as separate categories in its inspection methodology. Engineers have flagged in academic literature that the combination is something different from either one alone. There's no official combined risk protocol. Numbers 4 and 3 aren't about what's wrong with the bridge. They're about what's wrong with everything around it. There's a bridge on Highway 1 in Big Sur that is, by every structural measure, perfectly fine. The bridge is not the problem. In 2017, the Pfeiffer Canyon Bridge had to be demolished, not because the bridge failed, but because a landslide destroyed both approach roads and the bridge became an island. Big Sur communities were cut off for months. No road access, no mail delivery, no way in or out for emergency vehicles except by helicopter or boat. The bridge was rebuilt. The hillsides are still the same hillsides. Active slide zones sit at the approaches to several Highway 1 crossings right now, and the bridge itself being sound provides exactly zero protection against that. The bridge is fine. The land it connects to isn't. Number 3 puts you in fog. Not coastal haze, real zero-visibility fog on a Bay Area crossing, the kind that drops to 50 feet of sight distance while the on-ramp behind you was perfectly clear. Fog on a bridge behaves differently than fog on a road because the air over open water stays saturated in ways that land doesn't. You are on the span before you know it's fogged in. Multi-car pileups in bridge fog have happened on California crossings, documented multiple incidents, different bridges, different years. Fog warning systems exist on some spans, not all, and a warning sign doesn't help much if you can't see it. Number 2 is a danger that doesn't look like a danger at all. There is a heavily trafficked California bridge, urban, economically critical, where the inspection record shows deferred seismic work, deck deterioration, and failing expansion joints all at the same time. Individually, none of those deficiencies reach the numeric threshold that triggers closure under Caltrans methodology. All 3 together have no threshold because the system doesn't have a category for compound failure. It scores problems one at a time. Think about that. A bridge can be failing in 3 separate documented ways simultaneously and still not qualify for closure under the current rules. Public records requests in similar cases have turned up internal communications where engineers flagged the combined picture and were told to document it, monitor it, and revisit in 24 months. Tens of thousands of commuters cross it every day. The report says it's within tolerance. The engineers who write those reports, some of them, take different routes. That one bridge is a problem with a solution. It just requires someone to own the political cost of closing it. Number 1 is the problem behind the problem. California has over 1,800 bridges currently rated in poor condition by federal standards. The state with the highest earthquake risk in the contiguous United States has a multi-billion-dollar repair backlog and a funding model built on gas tax revenue, which is declining as electric vehicles take over, contracting exactly as the backlog expands. Here's what poor condition actually means in California's specific situation. It means a bridge past its service window, carrying loads it was never designed for in a seismic zone that's been reclassified since it was built, with deferred work accumulating on a structure that doesn't forgive deferred work. The retrofit program that launched after 1989 took decades and billions and still isn't complete. And some of what counts as completed is first-generation work done before the fault models were updated. California built its bridge network for a state of 10 million people. There are now 40 million. The faults that run under every bridge on this list don't care about funding cycles or political timelines or how long the maintenance queue is. They've been building pressure since before the first rivet was driven, and not one of them has ever missed a deadline.